Welcome back to our channel. This video is about graphing rational functions. The following are the important things we need to know in order to graph a rational function. First, we have the domain. In finding the domain, we have to find all x values which do not make the denominator 0. Next, we have the y-intercept. To find the y-intercept, we have to do the following. If 0 is not in the domain, then there is no y-intercept. If 0 is in the domain, then the y-intercept is the value of the function at x equals 0. Next, we have the x-intercept. In finding the x-intercept, we have to find the values of x where the numerator is 0 but the denominator is non-zero. In graphing a rational function, we also need to consider the asymptotes. First, we have the vertical asymptotes. In finding the vertical asymptotes, we have to find the values of x where the denominator of the reduced rational function is 0. For the horizontal asymptote, we consider the degree of the polynomial in the numerator and the denominator. So let n be the degree of the numerator and m be the degree of the denominator. If n is less than m, the horizontal asymptote is y equals 0. If n is equal to m, the horizontal asymptote is y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. If n is greater than m, there is no horizontal asymptote. Finally, we have the range. In order to find the range, we have to graph the function. Now, let us consider an example. To sketch the graph of f of x equals 3x squared minus 8x minus 3 over the quantity 2x squared plus 7x minus 4. First, we have to identify the domain. Note that f of x can be factored as follows. So the denominator of f of x can be expressed as the quantity 2x minus 1 multiplied by x plus 4. As you can see, the denominator will be 0 if x equals 1/2 or x equals negative 4. Thus, f is undefined in these points. Thus, the domain of f of x is the following set. Now we find the y-intercept. So let x equal 0. We have f of 0 equals to 0 plus 0 minus 3 over 0 plus 0 minus 4, which is equals to 3 over 4. Thus, the y-intercept is y equals 3 over 4. For the x-intercept, we let the numerator be 0. We have the quantity 3x plus 1 multiplied by the quantity x minus 3 equals 0. We get the equations 3x plus 1 equals 0 and x minus 3 equals 0. Hence, we have x equals negative 1/3 and x equals 3. Thus, the x-intercepts are x equals negative 1/3 and x equals 3. For the vertical asymptotes, let the denominator be 0. So we have the equations 2x minus 1 equals 0 and x plus 4 equals 0. Hence, we have x equals 1/2 and x equals negative 4. Thus, the vertical asymptotes are x equals 1/2 and x equals negative 4. Now, for the horizontal asymptote, we consider the degree of the polynomial in the numerator and denominator. So the polynomials in the numerator and denominator have equal degree. Hence, the horizontal asymptote is the ratio of the leading coefficients, that is, y equals 3/2. Finally, we have to identify the range. For the range, we first have to graph the function. We plot the intercepts and asymptotes on the Cartesian plane. We have y-intercept is y equals 3/4, x-intercepts are x equals -1/3 and 3, the vertical asymptotes are x equals 1/2 and x equals -4, and finally we have horizontal asymptotes y equals 3/2. Next, we construct a table of signs using the values of x that make either the numerator or denominator 0 as boundaries. We consider 5 intervals for the function f. If x is less than -4, we have the test point x equals -10. As you can see, the sign of f is positive, hence the graph is above x-axis. For the values between -4 and -1/3, we have the test point x equals -2. Observe that the sign of f is negative, hence it is below x-axis. For the values between -1/3 and 1/2, we have the test point x equals 0. We can observe that the sign of f is positive, hence the graph of the function is above x-axis. For the values between 1/2 and 3, we have the sign of the function is negative, hence the graph of f is below x-axis. Finally, if x is greater than 3, the sign of f is positive, hence the graph of the function is above x-axis. Next, we draw the sections of the graph through the zeros indicating the correct transition based on the table of signs. Again, based on the table of signs, we draw sections of the graph near the asymptotes. Now, we complete the sketch by connecting the arrowheads, making sure that the sketch passes through the y-intercept as well. We have the actual graph, which is obtained through a graphing software. Now, based on the graph, the range of the function is the set of all real numbers. And that ends our video. Thank you.